Hi, everyone, and welcome to our webinar about prototyping the Mercedes-Me app. My name is Julia, and I'll be your host today. Please head over to the chat box and leave us a message saying from where you're listening in today. We are always eager to see from where our ProtoPie users listen in our webinars. So head over to the chat. You should be able to leave comments and let us know from where you're joining in. Hi, Maria. Hi, Abby. Hi, Fredo. Okay, I see people are joining in from all over the world, literally Germany, the UK, Poland, Kenya, the Netherlands, Turkey, Ukraine. Hi, Ing. Bonjour, Amy. Hi, Chris. Hi, Julia from Italy. Okay, I can see people are still trickling in, so but we will wait a few more seconds before we get started. Hi, Anna from Portugal. Okay, then, while people join in, let's meet today's speakers. Today's session features MBition, a Mercedes-Benz software subsidiary based in Berlin, Germany. I'd love to introduce you to Szymon Koszelniak and Ferry Irsanto Brugianto, both of them UI, UX designers at MBition. Ferry and Szymon, would you like to say hi to our audience?
Sure. Hi, everyone.
Hi, everyone. Glad to be here.
Thank you so much. Okay, then, let us cover today's agenda. Today's webinar will start with a short introduction about ProtoPie. Then we will learn about the prototyping process behind the Mercedes-Me app, and we will wrap up with a Q&A session at the end. We would like to make the most out of the webinar today, so I would encourage all of you to ask questions during the Q&A session. So head over to the Q&A window and ask all your questions in there, and we will cover them at the end. Okay, then. First things first, what is ProtoPie? Well, ProtoPie is the easiest tool out there for turning interaction design ideas into high-fidelity prototypes. However, ProtoPie is not just a simple prototyping tool. Thanks to its various integrations, such as the Connect extension app, ProtoPie can handle all sorts of digital products, all the way from different industries, whether we're talking mobile, tablet, Internet of Things, smartphone, or automotive design, ProtoPie has got you covered. If you want to learn more about the ProtoPie automotive solutions, head over to protopie.io/solutions/automotive, or simply scan this QR code here on the screen. And my colleagues will also leave the link in the chat. Okay, then, we have a lot of things to cover today, so we will get right to it. I will let the MBition team take over the steering wheel, pun intended. Yeah, Szymon and Ferry, the stage is yours. I will stop sharing now.
Yeah, thanks. I'm starting sharing.
We can see your screen, Szymon.
Yes. Is it there now? Okay, cool. Thanks, Julia. So welcome everyone to our webinar. We are happy to see you all. We might be rushing a bit through some of the topics because we have plenty of slides. So before we begin, let's take a look on our agenda for today. We will start with personal and company introduction. From there, we will go to focus on Mercedes-Me product and deep dive in our component library approach. Next, Ferry is going to guide you through example workflow. We will end with small info about how we enable connected experience in our prototyping environment. let's start with personal introduction. So I will keep it short. I am UI UX designer with technical background. I used to work as a game artist, technical artist, designer in print, in both like in print and web area. In MBition in the automotive, I am since about 3.5 years. Oh my God. Sorry, something.
No worries, it can happen.
Yeah,
Yeah, I just wanted to
so
remind everyone, sorry, to use the everyone when sending messages in the chat.
Yep.
Thanks.
all right. Hi everyone, I'm Ferry. I'm UI UX designer, also specializing on prototyping with a background in design and also some technical backgrounds. I started off working around the same time with Shimon at MBition as a working student, and since about a year, I started working full-time there. So here's a quick sneak peek of our company profile to bring a better understanding of our product and upcoming points. So our company is a 100% subsidiary of Mercedes-Benz. We are part of Mercedes-Benz Software Hub and part of the research and development. MBition was founded in 2017 in Germany's capital city, Berlin. And since then, our headquarters is located there. And since November 2021, we have expanded our hub to Sofia, the capital city of Bulgaria. And altogether, in both locations, we have more than 900 employees of diverse nationalities. Simon, you're muted.
Okay. What do? We design the future of Mercedes-Benz infotainment systems. You could ask what infotainment or what is infotainment or what are the products that we actually do. There are some like different definitions on the internet, but in short, infotainment is a mix of information and entertainment, and that is provided to the user mostly via one display or multiple displays located in the car. In this video, like maybe it will be the easiest to like present it in the video. You will see some of these elements there, or actually all of them should be present. I have taken a video of new S-Class world premiere as example. Here is a little link in case you want to watch it, but it's already like 2 years old. So let's begin with playback.
Hi guys, thanks so much for being with us today. I'm just about to pick up the S-Class for a short test drive, except I'm not going anywhere. It's coming to me all by itself. Well, that's pretty cool, but it gets better. Let's get in.
It also protects those around, is attentive, and most importantly, takes care of everyone. But I stay in control. Always set the right mood. It's my partner. One that knows what I like and brings me to where I'd like to go next without getting lost. The new S-Class.
I will list elements a good eye could have catch in this short video. So what do we have there? It is instrument cluster. It's crucial for a driver. Then we have head-up display, something back then seen only in movies, now becoming more and more common. Yet another great way to support driver on his journey. We have head unit, which is the heart of infotainment system. And finally, passenger display or displays, depending on the car model. But it's not all. There is one more product that could be spotted there. And that is the one that we are going to focus on now. It's Mercedes Me application, released in October 2020 as companion app for Mercedes car owners and users. It allows some kind of interaction of an user with his car. Mercedes Me was also the first product that, at least for me, that I started to prototype with at MBition. We tried some different tools, but without going too much into detail, like we ended up with ProtoPie, and like I'm at least quite happy to work with that. We wanted to do, like when we started the approach with ProtoPie as well, we wanted to do it right because we knew our limitations, such as a relatively small team, time pressure, need of high fidelity prototypes for stakeholders. But we also knew that we have some solid foundations that we can build on, such as a component libraries already in place in Sketch and design system in place. So our experience with other tools have also shown that starting from scratch when building a prototype is not always the best idea, especially for high fidelity prototyping. Therefore, we wanted to try an approach with component libraries. And now we are going to focus on how we approach the prototyping libraries for Mercedes Me. During the process, we have established some guidelines and the best practices that became useful for us. Maybe you'll find something of that also handy as well. So one of the biggest thing is like, and actually it's gonna be all three here, is like about naming. In this case, variable naming. It allows to identify a bit faster than by just like clicking and checking in inspector, like what the variable type is. We are also like using, like in this example, you can see like we have created kind of bool variable, which is actually just a string variable. But in our logic, we are asking whether the string variable is false or true, and it allows us to very quickly see the condition. Then conditions naming, coming together basically, like when we have already variable naming, I can ask in condition, like whether it's false or true, and when I name the layer in the condition, like it also allows me to be faster without clicking to see what's going on there. And last from this group, triggers and responses naming. So we can also name the response, name the trigger. In this case, you can see, for example, this send leave page, trigger is having basically, like this layer is having the same name like the message. Next one. So you can also split your libraries in multiple and into smaller chunks. Initially, we partially did it also because of performance, because we had like quite a lot of components and they were like opening the library was a bit longer, but with the time we have learned that there are some other benefits out of it. So we have started to organize them into logical groups that also allowed us to work on different areas at the same time, but contributing to the same product at the end. For those multiple libraries, we have specific naming and color coding. So whenever user uses a specific component from a specific library, he can right away see that the name is, oh, it's beginning with that, and then the background is this, so it's for sure from the, I don't know, icons library. And the last one, it's very valid for, especially for cases where you have a lot of logic. It allows like grouping them into logical chunks will allow you to have a better overview. Also, when you stay consistent across different components, if you work with components and you use the same names for same functions, it also allows you to have a faster like get into it time. This one is valid if you want to stay flexible. So another lesson learned, try to use dynamic values. In this example, like instead of hard code the width, we use the width of the container. Something that sounds so obvious is not always so obvious. Like I've seen many users like doing like rather preferring hard code, and whenever they come back to a prototype, they need to like rebuild the prototype because like the element was just moved a little bit. To make it also user proof or like kind of like typo proof, we try to bring string values in conditionals like to the same formats. So for example, always to the uppercase. So in case someone is writing in lowercase or beginning like or having camel case whatsoever, it doesn't matter. At the end, we always compare to the uppercase. And very important thing, if you work with users or with like you're not a one person team, you work with multiple like colleagues that are contributing to the library, document your component. It really helps to understand the component. As mentioned on slide 20, we have divided our libraries into smaller pieces. I will be now just presenting these groups, but we will explain more about them in the next slides. So we have a helper library in the helper library lane. It's just it for now. Then we have asset libraries, and in asset libraries, we have icons, textile, static components. And last block is logic-based library block, which includes dynamic components and map components libraries. Those are the ones that are the most logic heavy and often include other components from other blocks. And talking about that, here is an example how component structure could look like in relation to each other and in relation to a scene. So let's say it's very abstract. So let's say we have a scene here, and me as a user, I'm putting from a component library a dynamic component on the scene that is including some elements from different libraries. So it's including one helper element and a textile. It could be, for example, just a header. Then I'm placing the background from static component library. Then I'm placing yet another bigger chunk, which, for example, could be a pop-up. And this pop-up is having a helper. That helper could be a timer that is counting when the pop-up should go off. And inside of this pop-up, I have a child component that is also including many other elements. And this child component could be, I don't know, let's say it's a button. And yet another dynamic component that is another header or a label with a styling. And the cool thing about it is yeah, it's going a bit quite complicated, but as long as the pro users are taking care of maintenance of this things, the end user doesn't need to think about it. He's just using the components with minimal logic. And also a good thing about that, all those elements can eventually communicate if we design them properly.
All right, and now let's take a closer look at our individual libraries, starting from our helpers libraries, which, as the name suggests, contains our helper components. And you may wonder what are helper components, and those are the components which purpose is strictly functional and does not include any designs or assets. Its main task is to receive and send back data between the parents and the child or the current scene and so on. Therefore, it is almost always used as a child inside of the different components. A classic example, as Shimon mentioned, would be a timer helper that receives signals to start a timer and then send back a signal whenever the timer is finished. And a more complex example would be our layer style helper, which mimics styling functionalities found in Sketch or Figma. Its task is to receive a color code defined in our design system and throws out the corresponding hex values while taking light and dark mode styling into consideration. And since the ProtoPie 7.6 update, we also incorporate JSON data to store our colors. And as you can see, the colors are stored in a JSON that contains different keys, such as here we have surface color 0, surface color 1, and so on. And inside of the helper component, a signal is received from the parents along with the value of the color code in a string format. And using the reg extract function from ProtoPie or also the nested JSON search, we search through the JSON file for that color code. And once the color code is found, we pass the JSON and send back the hex value to the parent based if it's a light mode or dark mode. And here is an example of the layer styling. I'm creating an interaction of tapping the gray square to send out the signal to the helper with a string value of the color code. In this case, the string value is called status warning, so reach status warning. I then receive the signal back along with the hex value as a response to recolor the square based on the hex value. And based on our design system, status warning is colored red. You would see here, I'm receiving it to a variable called hex color. And as a response, I'm recoloring the square based on this variable. And since we defined it already, that status warning is equals to red, then the square is recolored to that color. So helpers are applied throughout our assets components. This way we can achieve a consistent coloring without the need to play around with hex code. And so that we kind of mimic our design system. And here is an example applied to our dark mode coloring. So at the start of the scene, I'm sending signal to the current scene that tells the Boolean value of dark mode if it's true or false. And since the layer style helpers are placed inside of every assets component, or every static or text icons and so on, and the helper has a receiver for the dark mode styling, all components are restyled automatically with ease. In this video, I'm just changing between the light mode and dark mode with delays to showcase how the style helpers work. So next from our libraries is the icon library. And as the name states, it stores our icons. The idea of the icon library is that the icons should be easily replaceable via the overrides function found in ProtoPie, and the color should be easily changed. And most icons contains the layer style helpers to change their color. This is switching the icons through the overrides. So it's pretty simple. And since all icons contains the same triggers and response, the coloring logic stays intact after the switch. So yeah, this is like a contrast color, and then we have our accent primary colors and also secondary. So it's basically like a library from our colors. And yeah, dimension status warning, and we also have success.
Cool. Next one is textile library. It can be a nice idea when you want to ensure that the text size, colors, font remain consistent across all the components. It is, of course, a bit of work to create that logic, and adds quite a bit of complexity, but it's a trade-off when it comes to consistency. So you need to decide for yourself what do you want to achieve. Just like icons, textile library uses color helper. Apart from that, it includes a minimal logic to auto size itself. So whenever we have 2 lines, 1 line, and whenever needed, like, yeah, it can just adjust itself. Here is a little example. We can override the component with other components like in icons, and then we can also change color. We can also change label and visual way. And also we can change label via signal. In this case, it will be done via like after the tab happens. Last one is least complicated of all three in this block. So from the static components block, static components, like this particular static components in theory were supposed to have no logic, but since light mode and dark mode, it has changed a bit. Still, main idea of this library is to store the basic assets such as backgrounds. We use different formats like PNG, SVG, ProtoPie primitives, Lottie, depending on the needs and performance. And the idea was to have assets that can be easily exchanged if needed or if design changes. So it's like without breaking the complicated logic. Now the most important part now comes to our dynamic component library. This library is considered as our main library. It holds crucial interaction functionalities of the components. A component in this library can nest other components, like stated also on slide 23. It usually distributes signals from parent to the child components and vice versa. So there is a lot of communication. Components often use overridable variables such as the state of the button or position of a slider, etc. This is an example of dynamic component, which is a control slider. As you see right out of the box, it is already interactive. So it's like following the same, like basically the functionality that we have also in the original app. So as you can see, it can store variables regarding its state and position. Those variables can be overridden through send and response from the parent. It also sends out a signal after a successful interaction. So in this example, I'm receiving a signal from the slider telling me the slider has been operated. In that case, I'm sending changing the slider state to pending and back to normal after 4 seconds.
So another example of our dynamic components is the status line. The status line tells the status of specific features, such as whether the window is open or closed, or whether the car is locked or unlocked. Therefore, the status line component stores variables regarding the status line subtitle, and the status line subtitle. Those values can be overridden by parent signals, and the same logic applies that the component sends values to the parents regarding its status and title. And furthermore, the status line scales automatically based on the text height of the title and subtitle. So as you see here, although it does not look good in the editor view, but in the preview, it rescales automatically depending on this height. And this is an example of different components interacting with each other. In this case, we have like a toggle slider component, and the toggle slider is responsible to set the door state of opening and closing. And depending on the state, the signals are then distributed to individual components, such as here the status line, the car illustration component, and the slider itself. So here I'm just having this return slider swiped and set it to pending and check the previous state, whether it's close or open. And based on that, I'm calling the signals change door state in the current scene. And within this signal, I define what should happen if the state is closed or open. And based on that, I'm sending different signals to different components on how should they behave. So for example, I'm setting the status line title, or setting the status line status, or changing the car illustration. So you would see that here. Yep, so everything basically works just with 2 triggers in this case. And our last set of components are the map components. It utilizes the same concept from dynamic components library, but on a bigger scale. In the example, you see different kinds of interaction with all elements coming from our components library. And furthermore, a gyroscope sensor is also applied to detect the device rotation. And the user icon here is rotating automatically based on the device rotation. And you also see here the text input component is applied to search for addresses. And you would also see on the top right, the compass component rotate itself based on the map's rotation. And what's interesting here, you see coordinates of the users and vehicle's position is also stored in a variable to create this focusing animation. And this is regardless of where you are in the map. You would always focus to the vehicle or the user. So let's try to sum up. We knew that we need to minimize disadvantages of high fidelity prototyping, such as, for example, high effort of creating a prototype and low maintainability. We think that with our approach, we gain some benefits, such as we are saving time, since basic interactions are already defined. A ProtoPie project is also scalable, with more features can be added to an existing ProtoPie project. You'll see that in a later example in the next slides. And thanks to our guidelines, our prototype are way more maintainable. Collaborative work can also be achieved through components documentation so that different people can work on different libraries without much conflicts. We are also user-oriented. We want to save the user time, in this case, the designer time and effort, so that they can jump on right away and focus on the important part instead, for example, building the button logic from scratch. And the last point, and this is generally also valid in ProtoPie overall, we do not need to code this interaction to create the complicated ones, besides using logical thinking. Now I'll show you a quick workflow on how we expand a prototype using different methods, such as using our component libraries, using different templates, and also the classic sketch export method. So here I have my prototype showcasing our home tab. In the current state, user can open and operate the vehicle lock feature. So this is the ones previously shown in the previous slides. And let's say, for example, we want to expand our prototype and add the remote engine feature. We start off by looking at the concept of the feature from our concept team. In this example, the concept is then simplified. So we have here a start, pressing a start button, sending the page to pending, and then starting the engine, and then we have a stop button there, and so on. But usually there is other cases to be considered. But here is like a simple example. So then we start off building in ProtoPie using the templates we have created, showcasing different patterns of the pages. So the template not only consists of design layouts, but also logic of basic interactions. And once I've found the right template, I can just copy the scene to my Py file and then renamed everything or replace certain things such as the name of the variables, values being sent and received, wordings, and so on. So here I rename the variables to string car engine state instead of feature state. And I set everything, renaming the variables from the template. And after I rename those variables, I then try to try to check it first if it works, if these new variables work, and it shows that it does based on the same logic. So we are all set here from variable standpoint. What's left is just to rename the scene itself. So instead of the placeholder titles or the placeholder text, we can just rename everything based on the feature we want to create. In this case, the status of the engine. We can also replace the icons, obviously, and replace the button label. And also, since we did that on the editor, we want to do that also in this variable signals we're sending. So instead of this generic text of turn on, we can just write start. So here I'm renaming the button label. And here I'm renaming the status line whenever it's turning on and whenever it's turning off. And we can see that in motion. So you would see how fast it is to recreate a new scene using our templates and our components. So eventually what's left is I need to add a tap trigger and a jump response into the home tab to open and operate the remote engine. And since I don't have a close button here, I'm not using a tap trigger. Instead, I'm using a receiver from the leaf page component. That's because this close icon is embedded as a component. So here, and obviously the other way around, I need to create that in our home tab. I'm duplicating the tap trigger here in this case. And do a jump to the remote engine page. There you go. So in some cases, we might not need to use our component if the element is not planned to be interactive in the prototype. In that case, we can just use the export function or export that element directly from Sketch using the export import plugin. As an example, in the video, it is the info line element that should be showing whenever the engine is active, and also this cell items element that also should be showing. And in that case, I'm just using here a opacity response based on the state of the engine. So I'm setting up everything first regarding constraints, that it should stay at the bottom. And what's important is I'm renaming the containers and the elements here so that it's clear on our signals, and set everything to zero opacity at the beginning. And I'm checking here, how should I scale this bottom action bar whenever it's active? And I'm saving that value, in this case to 206. And based on whether the engine is on, I'm scaling the bottom action bar to 206 height, and also do the opacity response for the info line and the cell items. And in this case, I want it to be shown, so I put it to 100 for both. Renaming the response is also a good idea, so that we know later on. And obviously, after that, we would want to do the opposite for the off engine state. So changing the opacity to 0 and scaling back the bottom action bar to 150. You see that in motion, and yeah, it's behaving as expected. All right, now back to Shimon.
And here we go, connected experience. What does it mean in our context? In the beginning, we were showing all the possible devices that you can find in the car or you can use in connection to the car. We can also prototype targeting all those devices, and potentially all those prototypes on different targets can communicate with each other thanks to ProtoPie Connect. Not only that, we can also use own bridge apps to feed those prototypes with car data or different interaction points. And the nice thing is that you can test same prototype on mobile device or tablet. You can do so on laptop, but you can also do that in the real car with a proper setup or in the sitting bag. Unfortunately, we can go only very high level here, but I can only recommend to explore this huge world of possibilities whenever you have ProtoPie Connect, like you find time to use it, play around. You can build own bridge apps, as mentioned, like we have our own tool chain to, like that is communicating with ProtoPie Connect. Just explore it. We are almost done with our webinar, but before we say bye, I would like to grab your attention for one more second. You remember this video shown in the beginning, and you have seen this phone in the hands of Lewis Hamilton, and there is a little surprise here, like this prototype was actually made in ProtoPie. And with that, thank you. Like, we are done, so I think we can in a second move to our Q&A.
Amazing. Thank you so much, Ferry and Shimon, for these amazing insights. Yeah, like you mentioned, let's head over to the QA window and try to cover some of the questions. We do have a lot of them. I will try to cherry pick. Please don't be sad if we won't cover, but we will try to cover as many as possible in the time that we have today. Okay, then let's see. I will, first of all, let me reshare my screen. There you go. Up. Okay. So someone is asking, I think it was one of the first questions that was asked today. So you mentioned having around 900 employees in MBition. Are they all designers? And if not, how do you coordinate with the non-designers to ensure a cohesive product? Also, how do you manage to keep everyone using ProtoPie in sync with each other?
I am not sure how far I can answer this question, but yet I will at least try to answer parts of it. So no, those are not all designers. Like most of them is developers. Designer group is quite small, I would say, for the whole app. It's most implementation. There's like, yeah, I cannot go too much into detail where is done what. But yeah, how do we coordinate? I can just say on the example like of on the on the example of the team that was doing the Mercedes Me application, it's like no, or I even cannot, because like most of the designers are gone now. So I don't think I can elaborate too much on that one. Like I can just say from my experience, also from different companies, it's like ProtoPie back then was not having handoff. I personally was not using handoff too much. And what we were doing, like we were like, we are not I'm not ready to answer this question. So the thing is like
But
we are having user studies, right?
I can also elaborate on that. Like for the Mercedes Me, at least we also use ProtoPie in our design system page, and for that we showcasing how instead in this page we showcasing how certain components behave and how certain component scales. So to add to the documentation for these components.
Okay, I
Yeah.
hope that answers your question. And Shimon, you did mention something about handoff during your answer. Arthur is asking, how does collaboration with the mobile developers look like when using ProtoPie? Can you elaborate a little bit on that?
Like I think I was mistaken also, like the last question, like so I will still get bits on the last one. So when designers working with together, we were just a small group. So we were like just, we were just talking. We didn't needed like a big medium. We were a small team, so we could like just chat right away, me and Ferry, or with the other designers. And when it comes to developers, like unfortunately I was personally not using this feature. Like I was not doing that. Like I don't know if you have any experience, Ferry. Like Ferry was part of the team.
Like I guess for very minute and specific animations, we try to showcase that and how it behaves. But for the proper handover stuff, we use different tools.
Okay, I think this pretty much covers it. Let's see. This is an interesting one. I'm also curious to learn, how is prototyping with ProtoPie for seating bugs, if that applies? What does the access to instrument cluster looks like there?
I'm always asking myself how far I can go with the answer, right? It's like, but yeah, you basically need a proper hardware that will allow you to display like prototypes on your instrument cluster, whatever your instrument cluster target is. Or if you have a seating bug, you can basically, I don't think it's any confidential information, like you can take basically any device that has a similar aspect ratio, and you can let it being displayed in the, in this size that you want to, right? So in ProtoPie, like you just need to ensure that it will scale in a proper way. In case ProtoPie player is not covering it, you can still build your own bridge app that maybe will do your display aspect ratio properly on the target device. But as mentioned, it could be anything. It could be monitor, it could be like whatever.
Yeah, especially at the very beginning of the concept phase, it's also a good idea to test it via, for example, you have an iPad setup for the instrument cluster, for example, and then you have your laptop for the head unit, and also an extra screens for other devices in the car, so to say.
Okay, Kevin, I hope that's good enough for you. Maria is asking, so this is regarding your colors while separating dark mode and light mode.
Could you please repeat the question?
So
I think
it's
my
from
internet was down.
Maria Van Valen. How do you structure your colors while separating dark mode and light mode?
So if you're talking about the JSON data, now we have as a JSON element, we have these color codes. For example, the status warning, status success, and primary, secondary, and so on. And within that JSON element, we have another JSON list, which is the hex value of the light mode and hex value of the dark mode, and that's basically it. So we just need to search for the color code first, and then search for this, depending on whether you're in light mode or dark mode, you search for this hex value.
Yeah, but since it is a JSON format, you can like do whatever you want, right? You could have a group for a dark mode and a group for a light mode, instead of like having the light mode and dark mode variable like in each of the sub elements. So it's up to you.
Thank you. Also, in regards to the JSON, do you press the whole JSON into one variable, or do you pass it via connect? So this is from Philip.
Currently, we have the JSON as in one variable, at least for the layer style, and we also have another JSON for the text style, since that's more specific. But otherwise, yeah, we haven't not passed anything in connect yet.
Yeah, I'm not sure how to understand to pass it via connect, but yeah, we basically like it's in the helper component. So helper component is holding this data kind of as in a database that you request always to tell you what color it should be. So yeah, final like as an end result, still you can request it through connect, right? So some other prototype could ask this help, like I don't know, like, you know, some element in other prototype, like I want to get this color, but we are not passing the whole JSON, I guess. We are just, you know, asking for little pieces of it.
Thank you. Okay, now let's move over to some questions regarding components. Okay, so Christopher is asking, with an existing design system, do you have any best practices for setting up a comprehensive component libraries? What challenges or initial obstacles did you encounter? It's all the way at the top.
Yeah, that will be the first part, but I think the biggest obstacle is, of course, the scalability, like is the maintainability, because the bigger it grows, the more complicated it can be to design. And I think from at least like my experience with some different component libraries, it is really way easier to work on a component library that has already some defined rules, that has already some design system, than on something that is constantly changing, right? Because even with this, like that is also the reason why we came up with this static thing, so that whenever we change, we do like very basic changes. We do not destroy the interaction points. So it's like, yeah, it's quite complicated to be honest.
It's complicated.
And the static also is very helpful for building libraries that are not particularly finalized yet in terms of design from the designers. So we create the logics first, and we can even use placeholder elements for these assets. And later on, when the design is finalized, we can then replace everything while still maintaining the functionalities and not building it from scratch again.
Thank you. I hope this answers some of the other questions that are also related to updating components and so on. Okay, Sabrina Hupperts is asking, can you give more information about how to link HUD, head units, passenger display, and the other parts with ProtoPie? How do you create the interaction there? It's towards the end of the Q&A.
Yeah, reading that one. I am not, yet again, I am not sure, like, but it really depends. If you have your seating bug set up, like where you can take just, you know, any devices, for example, like you don't take the, like, so first of all, you will need ProtoPie Connect. I think this is valid. This is also what ProtoPie is saying, right? ProtoPie Connect is kind of your bridge, okay, bridge. It's not a bridge app, but it's the way to intercommunicate different prototypes. So this is the very, like the most important things you will need to do. Like, and when it comes like to target devices, when you want to need your real devices, like there is no right answer to it. I think it will depend on the company you're working at and like on the hardware setup, on the obstacles there with the network. It's all like, you know, I think mostly it's usually the technical limitations or technical requirements of the company than actual ProtoPie, because like the prototyping and ProtoPie will like gives you the tools to communicate. The rest is on you. So if you want to have a real data or whatsoever, you will need your own bridge apps probably.
Thank you, Shimon. Okay. This question comes from Steven Mancera. Does your current ProtoPie design system and design workflow only exist for the Mercedes-Me app, or does it also include other Mercedes experiences like the infotainment, passenger displays, and so on?
Yeah, short answer. We also use ProtoPie in other products as well. Yeah, that's
short and sweet.
yeah.
Thank
It's
you.
not it's not just specific to Mercedes-Me app.
Thank you, Ferry. Okay, I think we have time for a few more questions. Let's see. So Daniel is asking, do you also have a library in your design tool, Figma or Sketch? So are you building the screens in two tools?
Yeah, we have our for the Mercedes-Me app, for example, we have our own Sketch library as well. And for that, yeah, as mentioned, like this is where the designers are maintaining it, so not the prototypers, so to say. And for that, it can change in terms of visual, but we try to replicate it then in ProtoPie, so that later on, whenever we are doing user testing or like concept validation, everything can be replicated in ProtoPie. But that's actually one of the reasons why we're using the static ones, because at least for the Mercedes-Me app, the designs are somewhat finalized. But whenever like there's a redesign, for example, yeah, it's just replacing this assets basically.
Okay, thank you. Okay, let's cover one more. This is regarding documenting all these components. So how are you documenting all this great work of the components?
Should I, or you want Ferry? Like I can stop and you can add on it. Like I don't know. Like
Yes.
so, there was an idea to like we have created like, okay, as we have established the language, the visual language in our documentation and the guidelines. So we use the guides, so the documentation feature of ProtoPie. So each component can have a guide, and that's what we are doing. But what we did is we basically almost always use the first field, and we use our like the visual language, so with proper like header styles, etc., so that it's always kind of consistent and the same. And the idea behind that was that I wanted at some point, you know, to copy all of that like from just one field and put it somewhere, to document it somewhere, or being able to eventually like display that from ProtoPie via some kind of API. But that is a lot of work, and we ended up at the end just with having that in our guides in ProtoPie. So the like I would say like just maintainability of that approach, like with copying manually, would be like impossible to be done with so many components we have.
Thank you,
Like,
Shimon.
did I missed anything?
I think this is pretty
We
much it. Yeah, Harry, go ahead.
Yeah, maybe to add to that, we also have two types of documentation, at least in ProtoPie. We have a documentation for the user, so like telling what are the signals are being sent or received from this component, but we also have documentation for the maintainers. In this case, the maintainers will be, for example, me and Shimon. So we can understand exactly what's the logic behind the component itself.
Thank you. Well, we have approached the end of our webinar. We have to wrap up here. Thank you for all these amazing questions. I'm so sorry that we could not cover all of them today. Right. So before we wrap up, I would like to thank all of you for attending today's webinar. And as a token of appreciation for your participation, we would like to offer this discount code to our attendees. So use code ProtoPie Webinar 23 upon checkout and get 30% off our yearly and monthly pro plans. Rebecca is also going to post the code in the chat box. And there's a few more things that I want to share with you before we say goodbye. Our next webinar is about prototyping for food delivery apps, and it's featuring Wolt, a Finnish platform for food and merchandise delivery. So please go to the chat box and register via the link to save your free spot. And yeah, I hope to see you there. I also want to encourage all of you who haven't yet joined ProtoPioneers, our online community. Shimon and Ferry are already a part of that. They're very active in there. It's the best place to kind of get help from other ProtoPie users, share your ideas, and if you get stuck with baking your pies, you can always post there, and someone will help you out. And also, check out our bento profile if you want to stay updated with everything ProtoPie related, all our news and updates and releases. Yeah, so I want to thank Ferry and Shimon for graciously handling the Q&A and for participating in today's webinar. I hope you found it helpful and engaging. As always, I want to thank the ProtoPie team for their support. And I hope to see you at the next webinar with Walt. Thank you, everyone. I will let the chat open so everyone can kind of take their links for another like 3 minutes. Okay.
Yeah.
Bye-bye.
Yeah, from our side, thanks a lot as well, ProtoPie, and also thanks to everyone who joined.
Yeah,
Thank
thanks
you.
a lot.
Take care.